Hello everyone and welcome to yet another episode of Darko's Game Dev Cookbook. In today's episode I'll be talking about one of the sneakiest problems in games development and programming in general. A problem which comes in silently, slowly suffocates your computer and often goes away with a bang. Today I'll be talking about memory leaks. Let's go! We as humans are made of many functional parts that make us up as a whole. According to our brain, the main central point where all of our thinking happens is the brain. And while our brain is great for processing information and decision making in general, it will not be as efficient in doing so without a thing called memory. If you think about yourself, you are you mostly because of your experiences through your life. It's due to all the things you learned and experienced that you memorize that affect your decision making process. Your identity is mostly made out of these memories. Now when I think about this, but back to the point, we as humans are very prone to creating systems that are human-like. Computers definitely follow that rule, so if in simplified computer architecture, a computer is made up of its brain, which is also called the central processing unit, and then besides the brain or the CPU, there's also a thing called random access memory, or RAM for short. Here it's important to say that when I say memory, I only refer to the RAM and not the persistent storage unit like hard disks or solid-state drives. The reason why RAM memory has random in its name is the fact that any part of this memory can be accessed quite randomly at any point in time. If you think about your human memory, you also access it very randomly. For example, an external trigger of some kind could lead you to recall a certain memory from your, let's say, 6th birthday, and just before that you were thinking about those great tortillas you ate the other day. So it's very random and also contextual. Your computer does the same thing. When you run a program, let's say you run it from an external disk of some kind, what happens is that your computer will take that info from the disk and load it up into RAM. Once the program is in the memory, it starts running a set of instructions it's programmed to do. That could be pretty much anything. The important thing to say here is that once the program is running, it's not only reading from memory, it can also write to it. Let's say you have an AI program which generates pictures based on a query of some kind. These programs are quite popular nowadays, right? So let's say you run the program and that takes up a piece of your memory because all the instructions of the program need to be there for your CPU or the brain to be able to process it. You type in a query and the program generates a picture. The generated picture needs to be stored somewhere, right? So let's say in this case you store it in the RAM. Obviously you don't have unlimited memory. So if you continue typing queries and creating these pictures and the program just kind of creates them without cleaning the old pictures up, you will eventually fill the memory. Now this case is very vague and without going into details, this probably would not be a thing you would call memory leak, but bear with me for now. Also, before going further, we need to start differentiating between two types of memory that your program can use. Both live in your RAM. There's stack memory and heap memory. In the context of this video, stack memory you can imagine as memory your program will surely release once it stops running. The thing though, stack memory is static. What does this mean? Well, this means that you can use it when you know exactly how much memory you'll need. For example, if you knew you could store a maximum of 5 pictures with your cool AI image generating tool, you could make it always take up space for exactly 5 images. And you could have that space allocated on the stack. You also know that all of that memory will get freed once your program stops running. But what happens if you want to store more than 5 and you don't really know how many you will have created while the program is running? Well, that's where the heap memory comes into play. Heap memory is used for dynamic allocation, so if you want to store more images, you could keep creating them on the heap. The catch though, once you create something on the heap, its lifetime is in the control of the program that created it. If the program does not explicitly free the memory it took, it will not become available for any other program on your PC until your application terminates or you restart your computer. Here, it's also important to say that it's not a rule that the program termination will help, although modern mainstream operating systems like Windows do quite a good job here. But in general, nobody guarantees you that once some memory leaks, you will get it back once the leaky program is killed. This area is also interesting from the aspect of programming languages. For example, most games are built using C++. C++ as a language gives you a lot of freedom as a coder, including the freedom to manage memory to your own liking. This obviously can be dangerous if you don't know what you're doing or you're simply having a bad day. However, programming languages luckily evolve. For example, C++ has a thing called smart pointers now, which simplistically make sure that the allocated memory is managed well and gets freed once the related resources are not in use anymore. Now let's get back to examples and take a look at a game dev example. Let's say you're making a shooter game and you want to make it so that every time you shoot, a bullet is created. What a bullet is in this context is not really important, but let's say that each bullet takes a small chunk of your memory. Which memory will you use to create this bullet? Well, technically, you could say that you support up to 100 bullets, so you take that memory on stack, so the static memory, as soon as the game starts and use it for all the bullets you spawn. The good side of this is that you're sure that once you quit the game, the memory that was used for the bullets will get freed. The problem is that you're constantly taking up the space for 100 bullets, even if there's way less bullets active. Also, you're constrained to 100 bullets, which is not great if you have several players shooting with weapons with high rate of fire, for example. You would use those 100 bullets very fast. So you think about solutions and you hear about this cool way of taking memory dynamically using heap. You decide that each time you shoot, a new piece of heap memory will get claimed by your program instead of using those static 100 bullets, right? So you implement the solution and start playing the game, and after a few minutes you realize that the game is really sluggish. It started feeling so weird. The frame rate is dipping, your task manager is showing that your memory is almost entirely depleted. It's just a small prototype shooter game, so how could it possibly take up the whole RAM on its own? And after a while you realize you did a mistake of not cleaning up after yourself. You realize that every time a bullet is destroyed in your game, you don't free the heap memory you used for it. This causes constant growth in the usage of RAM, and the more bullets are created, the faster your memory will deplete. This is a classical example of a memory leak. Obviously, this example is quite basic. It's very basic. In practice, leaks don't present themselves in such an obvious manner, not usually at least. They are often hardly detectable, and they are there to beat you up in a marathon run, not in a sprint. If you imagine that your program leaks 1 kilobyte of memory each second, it would take it 194 days to fill up 16 gigs of RAM. So if you have programs constantly running in the background and you rarely check up on them, it might be the time to do that. There are numerous techniques to track memory leaks down. As I mentioned before, operating systems such as Windows have techniques for tracking program heap allocations and freeing the leaked memory once the program terminates. However, you should never ever rely on that. As a programmer, you tend to follow certain practices to minimize the risk. For example, practices like resource acquisition is initialization, or RAI for short, where the lifetime of the object is bound to its memory. A very simplified example of this would be making sure that the underlying memory of a bullet is freed when the bullet is destroyed in your game. There's also techniques in which programmers constrain the heap usage for their programs, or simply track heap usage during time and make sure that it's not growing indefinitely. Even when there's a lot of effort put into making sure that there is no memory leaking, it's still quite possible for it to happen and needs to be prevented by following good programming practices. Alright, that's everything I had for today's video. I hope that now you know what memory leaks are, and that you will look at them from a different and now much more informed perspective. If you liked the video, please do leave a like, it means a lot. If you like the content I'm creating in general, please do hit that subscribe button to not miss any of my future videos. Until the next time, enjoy!